Now in this lecture we'll answer two questions. In the first question we'll find out the value of line segment X that is inside this rectangle ABCD. In the second question we'll find out the value of the area of the green shape that is inside the semicircle. So we'll start with the first question. In the drawing we have rectangle ABCD. Inside rectangle ABCD we have a circle, and the tangent from point A to this circle is equal to 33 units in its length. And we also know that the tangent from point B to this circle is equal to 85 units in its length, and we are looking for the tangent from point C to this circle. What is the length of the tangent from point C to this circle? That is unknown, so we have to find out the value of this tangent that is defined as x, and we know that the tangent from point D to this circle is equal to 35 units in its length. Again, our mission is to find out the value of x, that is the tangent from point C to this circle. So first of all, we will define the center of this circle as O. We will define the point of tendency of the tangent from point A to this circle as E. We will define the point of tendency of the tangent from point B to this circle as F. We will define the point of tendency of the tangent from point C to this circle as T. And we will define the point of tendency of the tangent from point T to this circle as M. In the next step, we will join points O and E together by a straight line. Point O is the center of the circle, point E is the point of the circle itself, therefore OE is the radius of this circle that we define as R. Here we have the radius OE that is drawn to the point of tendency, and here we have rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. We have here tangent AB, that is tangent to this circle as point M. Point M is the point of tendency. And we have the radius OM that is drawn to the point of tendency. Therefore, according to this rule number 1, tangent AB will be perpendicular to the radius MO. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees according to this rule number 1. We can implement rule number 1 in our drawing. Why? Because in our drawing we have the radius OE that is drawn to the point of tendency. Therefore, according to rule number 1, this angle equals to 90 degrees. We join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself. Therefore, OM is the radius of this circle that is equal to R. And again, we have the radius OM that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. Likewise, we join points O and T together by a straight line. Again, here, point O is the center of the circle, point T is the point of the circle itself, therefore OT is the radius of this circle, and the radius OT is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees. And finally, we join points O and F together by a straight line. Point O is the center of the circle, point F is the point of the circle itself, therefore OF is the radius of this circle that is equal to R, and we have the radius OF that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees. Okay. In the next step, we join points A and O together by a straight line. By joining points A and O, we created here the right triangle, triangle AOE, the right green triangle, triangle AOE. We will implement the Pythagoras theorem on the right green triangle, triangle AOE. Repeat again, we will implement the Pythagoras theorem on the right green triangle, triangle AOE. Here, by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here, the hypotenuse is AO in the right green triangle, therefore the square of the hypotenuse is AO square. And it is equal to the sum of the squares of the perpendiculars, that is to say it is equal to OE square plus AE square. I repeat again, according to the Pythagoras theorem in the right green triangle, triangle AOE, AO square equals to OE square plus AE square. So AO square equals to OE square. OE equals to R, therefore OE square is R square plus AE square. AE equals to 33 units according to what is given to the question. Therefore AE square is 33 square. So in conclusion, according to the question number 1, I found out that AO square equals to R square plus 33 square. In the next step, we'll join points O and B together by a straight line. And we'll implement the Pythagoras theorem on the right yellow triangle, triangle OFB. Here by PT is aberration for Pythagoras theorem. According to the Pythagoras theorem, OB squared equals to OF squared plus FB squared. Okay, again, in the right yellow triangle OFB, according to the Pythagoras theorem, OB squared equals to OF squared plus FB squared. So OB squared equals to OF squared. OF equals to R, therefore OF squared is R squared plus FB squared. FB equals to 85, therefore FB squared is 85 squared. In conclusion, according to equation number 2, we found out that OB squared equals to R squared plus 85 squared. In the next step, we'll join points O and C together by straight line. And we'll implement the Pythagoras theorem on the right orange triangle OTC. On the right orange triangle OTC, by PT, or CO squared equals to TO squared plus TC squared. Repeat again, in the right orange triangle OTC, CO squared equals to TO squared plus TC squared. So CO squared equals to TO squared. TO is R, so TO squared is R squared plus TC squared. TC equals to X, therefore TC squared is X squared. So in conclusion, according to question number 3, we found out that CO squared equals to R squared plus X squared. In the next step, we'll join points D and O together by a straight line. implement the Pythagoras theorem on the right pink triangle, triangle MOD. On the right pink triangle, triangle MOD, according to the Pythagoras theorem, the whole square equals to MO square plus DM square. And then again in the right pink triangle, triangle MOD, according to the Pythagoras theorem, the O square equals to MO square plus DM square. So DO square equals to MO square. MO equals to R, therefore MO square is R square plus DM square. DM equals to 35, therefore DM square is 35 square. In conclusion, according to equation number 4, we found out that DO square equals to R square plus 35 square. In the next step, I will copy the 4 equations that we derived from the Pythagoras theorem in a new page. According to equation number 1, we found out that AO square equals to R square plus 33 square. According to equation number 2, we found out that BO square equals to R square plus 85 square. According to equation number 3, we found out that CO square equals to R square plus X square. And finally, according to equation number 4, we found out that DO square equals to R square plus 35 square. Okay, so in the next step I will copy rectangle ABCD with its circle inside it, and then analyze the rectangle with the circle. So here we have rectangle ABCD. So this is rectangle ABCD with circle. The center of the circle is at this point, point O. We know that all the angles inside the rectangle are right angles, so this angle equals to 90 degrees. This angle equals to 90 degrees. This angle equals to 90 degrees. And this angle, it is also equals to 90 degrees. In the next step, from the center of this circle, that is to say from point O, we will draw perpendicular on AB. And we will extend the perpendicular from point O to DC. So here, this angle equals to 90 degrees, and this angle, it is also equal to 90 degrees according to our construction. We find the touching point of the perpendicular from point O and AB is T. So we draw perpendicular from point O on AB. But because of the fact that side AB is parallel to side DC, it means that the perpendicular to AB must be also perpendicular to DC, because again AB is parallel to DC. So here this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to what I mentioned here. We define the touching point of the perpendicular from point O and DC as M. In the next step, from the center of the circle, that is to say from point O, we draw perpendicular on BC. And we'll extend the perpendicular towards AD. So here this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BC is point N. Again, because of the fact that side BC is parallel to side AD, it means that the perpendicular from point O to BC must be also perpendicular to AD, again because AD is parallel to BC. So here this angle will be equal to 90 degrees, and this angle equals to 90 degrees according to what I mentioned. And we define the touching point of the perpendicular from point O and AD is point H. So in quadrilateral AT edge O, we have 1, 2, 3 right angles. The sum of right angles is 270 degrees, plus the size of this fourth angle in total must be equal to 360 degrees. So the missing angle must be equal to 90 degrees, because 270 degrees plus 90 degrees is equal to 360 degrees. That is the sum of the angles in any quadrilateral. Okay, so quadrilateral AT edge O has 4 right angles, therefore quadrilateral AT edge O is a rectangle. Okay, likewise in quadrilateral AODM, this quadrilateral we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, therefore quadrilateral edge ODM that has 4 right angles, it is a rectangle. Likewise the quadrilateral TBON we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, and therefore quadrilateral TBNO is a rectangle. And finally, in quadrilateral ONMC, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, and therefore quadrilateral ONMC is a rectangle. So we found out that inside the big rectangle ABCD we have 4 small rectangles. Okay. We join points A and O together by a straight line. And we implement the Pythagoras theorem on the green right triangle, triangle ATO. According to the Pythagoras theorem, in the green right triangle, triangle ATO, AO square before that we define side AH as edge 1, we define side HD as edge 2, we define side AT as B1, and we define side TB as B2. We have the rule that the opposite sides of a rectangle are equal to each other. So in rectangle AT edge O, AT equals to edge O, but we know that AT equals to B1, therefore edge O must be also equal to B1. Likewise, in rectangle AT edge O, AH equals to TO, but we know that AH equals to edge 1, therefore TO must be also equal to edge 1. Likewise, in rectangle edge ODM, edge O equals to DM, but we know that the edge O equals to B1, therefore DM must be also equal to B1. Likewise, we know that HD equals to OM, but we know that HD equals to H2, therefore OM must be equal to H2. Likewise, in rectangle TBON, TO equals to BN, but we know that TO equals to edge 1, therefore BN must be also equal to edge 1. We also know that TB equals to ON, but TB equals to B2, therefore ON must be also equal to B2. And finally, in rectangle ONMC, side ON equals to side MC, but we know that ON equals to B2, therefore MC must be also equal to B2, and we also know that OM equals to NC, but OM equals to H2, therefore NC must be also equal to H2. Now we'll implement the Pythagoras theorem on the right green triangle, triangle AOT. According to the Pythagoras theorem, AO square equals to B1 square plus H1 square. Repeat again. In the right great triangle ATO, AO square equals to B1 square plus H1 square. In the next step, we join points B and O together by a straight line. And we implement the Pythagoras theorem on the right yellow triangle, triangle TBO. The right yellow triangle, triangle TBO. According to the Pythagoras theorem, BO square equals to H1 B2 square plus H1 square. So in the right yellow triangle TOB, according to the Pythagoras theorem, BO square equals to B2 square plus H1 square. In the next step, we will join points O and C together by a straight line. And we'll implement the Pythagoras theorem on the right orange triangle, triangle ONC. The right orange triangle, triangle ONC. According to the Pythagoras theorem, CO square equals to B2 square plus H2 square. Repeat again, in the right orange triangle ONC, according to the Pythagoras theorem, CO square equals to B2 square plus H2 square. And finally, we join points D and O together by a straight line. And we implement the Pythagoras theorem in the right pink triangle, triangle ODH. In the right pink triangle, triangle ODH, according to the Pythagoras theorem, we get that DO square equals to B1 square plus H2 square. Repeat again, in the right orange triangle DHO, according to the Pythagoras theorem, DO square equals to B1 square plus H2 square. So here you actually have two equations, two different equations for AO square. We have two different equations for BO square, two different equations for CO square, and two different equations for DO square. So we will create 4 more equations. According to equation number 1, a whole square according to this first equation must be equal to a whole square according to the second equation. A whole square according to equation number 1 is r square plus 33 square. And it must be equal to a whole square according to this equation number 2, that is b1 square plus h1 square. Likewise, we create equation number 2 that states that b whole square according to this equation number 1 must be equal to b whole square according to this equation number 2. B whole square according to equation number 1 is r square plus 85 square. And it must be equal to b whole square according to equation number 2. This equation that is b2 square plus h1 square. In the next step, we create equation number 3 that states that c whole square according to equation number 1 must be equal to c whole square according to equation number 2. C whole square according to equation number 1 is r square plus x square. And it must be equal to c whole square according to this equation number 2, that is b2 square plus h2 square. And finally, we create equation number 4 that says that d whole square according to this equation number 1 must be equal to d whole square according to this equation number 2. D whole square according to equation number 1 is r square plus 35 square. And it must be equal to d whole square according to this equation number 2, that is b1 square plus h2 square. So we created here 4 equations. In the next step, we subtract equation number 1 from equation number 2. So it is 2 minus 1. This way we create equation number 5 that states on this side of equation number 2 we have r squared plus 85 square minus equation number 1. Here we have minus r square plus 33 square now we get to the other side of equation number 2 is equal to b2 square plus h1 square minus equation number 1. Here we have minus b1 square plus h1 square. In the next step, we'll open the brackets of this equation number 5, and we'll get that according to equation number 5, r square plus 85 square minus r squared minus 33 squared equals to b2 squared plus h1 squared minus b1 squared minus h1 squared. So here we have r squared minus r squared is 0, so r squared will get cancelled. On the other side of the equation number 5 we have h1 squared minus h1 squared is 0, so h1 squared will also get cancelled. So what is left from equation number 5 after we cancel those two expressions? What is left is actually in this side of equation number 5 we left with 85 squared minus 33 squared then in the other side of equation number 5 we have here b2 squared minus b1 squared. So according to equation number 5 we found out that 85 squared minus 33 squared equals to b2 squared minus b1 squared. In the next step we subtract equation number 3 from equation number 4. So it is 4 minus 3. 4 minus 3. In this side of equation number 4 we have, so in this way we get equation number 6. In this side of equation number 4 we have r squared plus 35 squared minus equation number 3 we have here minus r squared plus x squared. Then in the other side of equation number 4 we have here b1 squared plus h2 squared minus equation number 3 we have here minus b2 squared plus h2 squared. In the next step we'll open the brackets of this equation number 6, and we get that according to equation number 6 r squared plus 35 squared minus r squared minus x squared equals to b1 squared plus h2 squared minus b2 squared minus h2 squared. R squared minus r squared is 0, so r squared will get cancelled. Here we have here h2 squared minus h2 squared is 0, so h2 squared will also get cancelled. So what is left from equation number 6 after we cancel those two expressions? What is left is actually in this side of equation number 6 we have 35 squared minus x squared, and the other side of the equation number 6 we have b1 squared minus b2 squared. Okay. In the next step we'll multiply this equation number 6 by minus 1, and we get that according to equation number 6 minus x squared times minus 1 is plus x squared, 35 squared times minus 1 is minus 35 squared, and it is equal to minus b2 squared times minus 1 is plus b2 squared, and b1 squared times minus 1 is minus b1 squared. So according to equation number 6, we found out that x squared minus 35 squared equals to b2 squared minus b1 squared. While according to equation number 5, we found out that 85 squared minus 33 squared equals to b2 squared minus b1 squared. In the next step, we'll create equation number 7 that states that b2 squared minus b1 squared according to equation number 5 must be equal to b2 squared minus b1 squared according to equation number 6. Okay. So b2 squared minus b1 squared according to this equation number 5 is 85 squared minus 33 squared. And it must be equal to b2 squared minus b1 squared according to this equation number 6, that is actually x squared minus 35 squared. So according to equation number 7, we found out that 85 squared minus 33 squared equals to x squared minus 35 squared. The next step, we'll add 35 squared to this equation number 7, and we'll get that according to equation number 7, 85 squared plus 35 squared minus 33 squared equals to x squared. 85 squared is 7,225 plus 35 squared. 35 squared is 1,225 minus 33 squared. Minus 33 squared is minus 1,089. And it is equal to x squared. Here, 7,225 plus 1,225 is 8,450 minus 1,089 equals to x squared. So 8,450 minus 1,089 is 7,361, that is equal to x squared. So according to equation number 7, we found out that x squared equals to 7,361. Here we'll take a root out of this equation number 7, and we get that x equals to plus minus the square root of 7,361. So here we will have two solutions that are possible for x. The positive square root of 7,361 and the negative square root of 7,361. But because of the fact that x is a length, s is a length, it must be a positive number. So we take into account only the positive solution. That is to say, x equals to the positive square root of 7,361. That is to say, it is equal to 85.796 units. Okay, so actually found out that the value of the line segment that we are looking for, line segment x, equals to 85.796 units. We finished with the first question. In the next step, I will present to you the second question, and we'll solve the second question in two different methods. in the drawing we have a semicircle. Inside the semicircle we know that AB equals to 6 units. AB is the diameter of the semicircle, that is equal to 6 units. And we know that angle BAC equals to 30 degrees, and our mission is to find out the area of the green shape. Okay, so let's start with the first method. Here we will define the center of the semicircle as O. We know that the diameter of the semicircle is equal to 6 units, and the radius is half the diameter. That is to say, the radius must be equal to 6 over 2, that is 3 units. So the radius OA will be equal to 3 units, and the radius OB must be also equal to 3 units. In the next step, we will join points O and C together by a straight line. Point O is the center of the circle, point C is the point on the circle itself, therefore OC is the radius of the circle, that is equal to 3 units. So inside triangle AOC, here we have in triangle AOC, side AO equals to side OC, they are both equal to 3 units, therefore they are equal to each other. And we have the rule that in front of equal sides, we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of the equal sides must be equal to each other. But we know that this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So in triangle AOC, this angle equals to 30 degrees, this angle equals to 30 degrees, 30 degrees plus 30 degrees is 60 degrees. Therefore, the missing angle must be equal to 120 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Okay. So, in the next step, I will present to you how to find out the area of any sector. So here we have sector AOB. This is sector OAB. First of all, the sign for a sector AOB, the rounded side above the AOB is the sign for sector AOB. So this means sector AOB. And therefore the area of sector AOB will be this. This is the area of sector AOB. So what is the area of sector A or B? The area of sector A or B. Here we know that AO equals to R, or B also equals to R. R is the radius of the circle that contains the sector A or B. Theta is the angle between the legs of sector A or B. So the area of this sector, sector A or B, will be equal to pi r square times theta over 360 degrees. Okay, I'll explain you what is the meaning of this equation. Here, the ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the entire of the area of the entire circle, and when we will multiply this relative percentage by the area of the entire circle, that is pi r square, we'll get exactly the area of this sector, sector A or B. Again, the ratio theta over 360 degrees gives us the relative percentage that this sector occupies out of the area of the entire circle, and when we will multiply this relative percentage by the area of the entire circle, that is pi r square, we'll get exactly the area of this sector, sector A or B. Okay? We'll use the new formula in order to find out the area of this sector, sector A or B. So I'll copy sector A or B here, and we find out the area of this sector according to the new formula. So this is sector A or C that I copied from the original drawing. According to the new formula, the area of this sector, sector A or C, will be equal to pi r square. R, the radius of this semicircle that contains sector A or C, equals to 3 units. R equals to 3, therefore pi r square is pi 3 square times theta over 360 degrees. Theta is the angle between the legs of the sector, that is actually 120 degrees. Theta equals to 120 degrees over 360 degrees. 3 square is 9, so this expression in total equals to 9 pi, and 120 degrees over 360 degrees is 1/3. That is to say, this expression in total equals to 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So I found out that the area of this sector, sector A or C, equals to 3 pi square units. In the next step, I will present to you a new formula for the area of any triangle, and we will use the new formula in order to find out the area of triangle A or C. According to the new formula, if we have a triangle AOC, that could be any triangle, if we have triangle ABC, that could be any triangle. This is triangle ABC. And we know that the length of side AB of triangle ABC is A units. Side AC equals to B units in its length. And the angle between side AB and side AC is theta. Then, according to the new formula, the area of this triangle ABC, area of triangle ABC will be equal to A times B times sinus theta over 2. Again, the area of this triangle ABC equals to A times B times sinus theta over 2. We use this new formula in order to find out the area of triangle AOC. So I copy triangle AOC here and we implement the new formula in order to find out the area of triangle AOC. So this is triangle AOC that I copied from the original drawing. According to the new formula, the area of this triangle AOC will be equal to AO times OC times sinus 120 degrees over 2. AO is free. OC is also free. Sinus 120 degrees is square root of 3 over 2, all divided by 2. 3 times 3 is 9, so in the numerator we have in total 9 times square root of 3. 2 times 2 is 4, so in the denominator we have 4. So in conclusion, we found out that the area of this triangle AOC equals to 9 times square root of 3 over 4 square units. We have already found out that the area of sector AOC equals to 3 pi square units. But what is actually the area of the green shape? From the drawing, it is very easy to see that the area of this green shape equals to the area of sector AOC minus the area of triangle AOC. Repeat again. The area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. So found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units, or in terms of numbers it is equal to 5.53 square units. We finished with the first method. In the next step, I will present to you how to find out the area of the green shape according to the second method. According to the second method, the area of this green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again. According to the second method, the area of this green shape will be equal to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. What is the area of the semicircle? The area of the semicircle equals to the area of the circle over 2. The area of the circle is pi r squared, and if we divide it by 2, we get the area of the semicircle. Here r equals to 3, so pi r squared is pi times 3 squared over 2. 3 squared is 9, so here in total this expression equals to 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out that the area of triangle AOC is equal to 9 times square root of 3 over 4 square units. The only thing that is left to do in order to find out the area of the green shape according to the second method is to find out the area of sector COB. In order to find out the area of this sector COB, we have to find out the angle between the legs of sector COB. AB is the diameter of the semicircle, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line AB at point O, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So which angles we have at the upper side of AB at point O? We have here this angle that is equal to 120 degrees plus the missing angle. In total they must be equal to 180 degrees. So the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB at point O to 180 degrees, this angle must be equal to 60 degrees. So in the next step I will copy sector COB in a new page and find out the area of this sector, sector COB, according to the new formula. So this is sector COB, that they copied from the original drawing. According to the new formula, we know that the area of any sector is equal to pi r squared times theta over 360 degrees. R is the radius of the circle that contains the sector, and theta is the angle between the legs of the sector, that is this, in this case is 60 degrees. Here the radius of the semicircle is 3, so R equals to 3. So the area of our sector, sector COB, according to the new formula, equals to pi r squared. R is 3, so pi r squared is pi 3 squared times theta. Theta is 60 degrees, so it is 60 degrees over 360 degrees. 3 squared is 9, so in total this expression equals to 9 pi. 60 degrees over 360 degrees is 1 over 6, so in conclusion, in total, this expression equals to 9 pi over 6. Okay, so the area of sector COB will be equal to 9 pi over 6 square units. We divide both the numerator and the denominator by 3. 9 over 3 is 3, so in total in the numerator we have 3 pi. 6 over 3 is 2, so in conclusion we found out that the area of sector COB equals to 3 pi over 2 square units. Now we can find out the area of the green shape. I'll repeat again. The area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. We have already found out that the area of the semicircle is equal to 9 pi over 2 square units minus the area of triangle AOC. We have already found out that the area of triangle AOC equals to 9 times square root of 3 over 4 square units, and finally we have already found out that the area of sector COB equals to 3 pi over 2 square units. 9 pi over 2 minus 3 pi over 2 is 6 pi over 2, so it is 6 pi over 2 minus 9 times 4 to 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi minus 9 times 4 to 3 over 4. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times 4 to 3 over 4 square units, so in terms of numbers it is equal to 5.53 square units. So we finish with the second method, and with the second question. In the next step, I'll summarize the lecture. I'll start with the first question. So, in the drawing, we have rectangle ABCD. Inside rectangle ABCD, we have this circle. The tangent from point A to this circle is equals to 33 units in its length. The tangent from point B to this circle equals to 85 units in its length. The tangent from point C to this circle is unknown, is equal to x, so we have to find out the value of x. And finally, the tangent from point D to this circle equals to 35 units in its length, and our mission is to find out the value of the tangent from point C, or the value of line segment CT is equal to x according to what is given as the question. Okay, so first of all, here we know that we define the center of this circle as O. We have the radius OE that is drawn to the point of tendency, therefore according to rule number 1 this angle equals to 90 degrees. We have the radius OM that is drawn to the point of tendency, therefore according to rule number 1 this angle equals to 90 degrees. Likewise, we have the radius OF that is drawn to the point of tendency, therefore according to rule number 1 this angle equals to 90 degrees. And finally, we have the radius OT that is drawn to the point of tendency, therefore this angle equals to 90 degrees according to rule number 1. We join points A and O together by a straight line. In this way, we created the green right triangle AOE. According to the Pythagoras theorem, AO square equals to OE square plus AE square. Repeat again. And the green right triangle AO square equals to OE square plus AE square. OE equals to R, AE equals to 33. So in conclusion, we found out that according to equation number 1, AO square equals to R square plus 33 square. Then we joined points O and B together by a straight line. In this way, we created the yellow right triangle OFB. This yellow right triangle OB square equals to OF square plus FB square. OF is R, FB is 85. Again, I repeat again. OB square in the yellow right triangle, OB square equals to OF square plus FB square. OF is R, FB is 85. So here we get that OB square equals to R square plus 85 square. And then we joined points C and O together by a straight line. In this way, we created the orange triangle, triangle COT. In the orange triangle, according to the orange right triangle COT, according to the Pythagoras theorem, CO square equals to TO square plus TC square. TO equals to R and TC equals to X. Repeat again, according to the Pythagoras theorem, in the orange right triangle, CO square equals to R square, CO square equals to TO square plus TC square. TO is R and TC is X, so therefore CO square equals to R square plus X square, according to equation number 3. Then we join points D and O together. In this way, we created the pink right triangle OMD, according to the Pythagoras theorem, and the right pink triangle DOM. DO square equals to MO square plus MD square. MO equals to R. MD equals to 35. So again, according to the Pythagoras theorem, in the right pink triangle, DO square equals to MO square plus DM square. MO is R and DM is 35. So in conclusion, we found out that according to equation number 4, DO square equals to R square plus 35 square. Then I copied the 4 equations that we derived from the Pythagoras theorem in a new page. And then I copied a rectangle ABCD with its circle inside this. This is rectangle ABCD with its circle. And then from point O, we draw perpendicular on AB. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Then we extended the perpendicular towards DC. Because of the fact that side AB is parallel to side DC, it means that the perpendicular from point O to AB must be also perpendicular to DC, again because of the fact that side AB is parallel to side DC. Therefore, this angle equals to 90 degrees and this angle also equals to 90 degrees. Then from point O, we go perpendicular on BC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Then we extended the perpendicular from point O towards AD. So because of the fact that side BC is parallel to side AD, it means that the perpendicular to BC must be also perpendicular to AD. So this angle equals to 90 degrees and this angle equals to 90 degrees according to what I mentioned. So in quadrilateral AT edge O, we have 1, 2, 3 right angles. Therefore the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. 270 degrees plus 90 degrees, it is 360 degrees, that is the sum of the angles in any quadrilateral. So, quadrilateral AT edge O that has 4 right angles, it is a rectangle. Likewise, in quadrilateral edge ODM, we have 1, 2, 3 right angles, therefore the fourth angle must be equal to 90 degrees, therefore quadrilateral edge ODM is a rectangle. Likewise, in quadrilateral TBON, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, therefore quadrilateral TBON is a rectangle. Likewise, in quadrilateral ONMC, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees, therefore quadrilateral ONMC is a rectangle. So inside the big rectangle ABCD, we have 4 small rectangles. Okay, then we joined points A and O together by a straight line. We implemented the Pythagoras theorem on the ring right triangle ATO. According to the Pythagoras theorem, AO square equals to b1 square plus h1 square. Again, in the algebraic triangle, a square equals to b1 square plus h1 square. Then we join points O and B together by a straight line. In the yellow white triangle, OTB according to the Pythagoras theorem, BO square equals to H1 square plus B2 square. Again, in the yellow white triangle, BO square equals to B2 square plus H1 square. Then we join points O and C together by a straight line. In the orange white triangle, according to the Pythagoras theorem, CO square equals to B2 square plus H2 square. Okay, again, in the orange white triangle, CO square equals to B2 square plus H2 square. And finally, we join point D and D together by a straight line, according to the Pythagoras theorem. DO square equals to B1 square plus H2 square. Repeat again. In the orange right triangle, DO square equals to B1 square plus H2 square. So we have two different expressions for AO square, we have two different expressions for BO square, we have two different expressions for CO square, and we have two different expressions for DO square. Okay? So we created four another equations. According to the first equation, AO square according to equation number 1 must be equal to AO square according to equation number 2. Then according to the second equation that we created, BO square according to this equation, equation number 1 must be equal to BO square according to this equation, equation number 2. Then we created equation number 3 that says that CO square according to this equation, equation number 1 must be equal to CO square according to this equation, equation number 2. And then finally we created equation number 4 that states that DO square according to this equation, equation number 1 must be equal to DO square according to this equation, equation number 2. So those are four equations that we created. Then we subtracted equation number 1 from equation number 2. So it is 2 minus 1. In equation number 2 we have r square plus 85 square minus equation number 1 we have here r square plus 33 square. That is equal, then we subtracted this side of equation number 2 minus equation number 1. In this side of equation number 2 we have b2 square plus h1 square minus equation number 1. We have here b1 square plus h1 square. Then we open the brackets of this equation, equation number 5, and we get that r square plus 85 square minus r square minus 33 square equals to b2 square plus h1 square minus b1 square minus h1 square. R square minus r square is 0, so r square will get cancelled. On the other side of equation number 5, we have h1 square minus h1 square is 0, so h1 square also will get cancelled. So what is left from equation number 5 after we cancel those two expressions? What is left? In this side of equation number 5 we left only with 85 square minus 33 square. That is equal to b2 square minus b1 square. Then we subtracted equation number 3 from equation number 4. So it is 4 minus 3. In equation number 4 we have here r square plus 35 square minus equation number 3 we have here r square plus x square. Then in the other side of equation number 4 we have b1 square plus h2 square minus equation number 3 we have here b2 square plus h2 square. Then we open the brackets of this equation, equation number 6, and we found out that r square plus 35 square minus r square minus x square equals to b1 square plus h2 square minus b2 square minus h2 square. R square minus r square is 0. h2 square minus h2 square is also 0. What is left from equation number 6 after we cancel those two expressions? In this side of equation number 6 we have 35 square minus x square. That is equal to b1 square minus b2 square. We multiply this equation number 6 by minus 1. And we found out that x square minus 45 square equals to b2 square minus b1 square. Then we created equation number 7 that states that b2 square minus b1 square according to this equation number 5 must be equal to b2 square minus b1 square according to this equation number 6. Okay, so according to equation number 7, we found out that 85 square minus 33 square equals to x square minus 35 square. We added 35 square to this equation number 7, we found out that according to equation number 7, 85 square plus 35 square minus 33 square equals to x square. 85 square is 7,225 plus 35 square. 35 square is 1225 minus 33 square minus 33 square is minus 1089. 7,225 plus 1225 is 8,450 minus 1089 equals to x square. 8,450 minus 1089 equals to 7,361, that is equal to x square. So according to equation number 7, we found out that x square equals to 7,361. We took out of this equation number 7, and found out that x equals to plus minus the square root of 7,361. But because of the fact that x is a length, x is a length, it must be a positive number. So we take into account only the positive answer. That is to say, x equals to 85.796 units. Okay, so we finished the first question. Then I presented to you the second question, and we solved the second question in two different methods. In the drawing we have a semicircle. We know that angle BAC equals to 30 degrees. We know that AB equals to 6 units. AB is the diameter of the semicircle. It is equal to 6 units. And we have to find out the area of the grid shape. So we define the center of this semicircle as O. The diameter of this semicircle is 6 units, and the radius is half the diameter. That is to say, the radius must be equal to 6 over 2, that is 3. So the radius AO equals to 4 units, the radius OB also equals to 4 units. Then we join points O and C together by a straight line. Point O is the center of the semicircle, point C is the point of the semicircle itself, therefore OC is the radius of the semicircle, that is equal to 3 units. So in triangle AOC, those two sides are both equal to 3 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. But this angle equals to 30 degrees, therefore this angle must be also equal to 30 degrees. So inside triangle AOC, this angle equals to 30 degrees, this angle also equals to 30 degrees. 30 degrees plus 30 degrees is 60 degrees. Therefore, the missing angle must be equal to 120 degrees according to the rule that the sum of the angles in a triangle is equal to 180 degrees. Then I explain to you how to find out the area of any sector. So this is sector AOB. The two legs of the sector are the radii of the semicircle that contains the sector, that is equal to R. The angle between the legs of the sector is theta. So the area of this sector, sector AOB, equals to pi r squared times theta over 360 degrees. The ratio of theta over 360 degrees gives us the relative percentage that the sector occupy out of the entire circle, out of the area of the entire circle. And then when we will multiply this relative percentage by the area of the entire circle, that is to say by pi r squared, we get exactly the area of this sector. Again, theta over 360 degrees is a ratio that gives us the relative percentage that this sector occupy out of the area of the entire circle. And then when we multiply this relative percentage by the area of the entire circle, we get exactly the area of this sector. So the relative percentage that is theta that this sector occupy out of the entire circle is theta over 360 degrees times the area of the circle will give us exactly the area of this sector. We use the new formula in order to find out the area of sector AOC. This is sector AOC. We call it sector AOC here. This is sector AOC. The radii of the semicircle is 3, so AO equals to 3, OC equals to 3, and the angle between the legs of sector AOC is 120 degrees. So the area of sector AOC is pi r squared. R is 3, so pi r squared is pi 3 squared, times theta is the angle between the legs of the sector that is 120 degrees over 360 degrees. So pi 3 squared is 9, so in total this expression equals to 9 pi. 120 degrees over 360 degrees is 1/3, so in total this expression equals to 9 pi over 3. 9 over 3 is 3, so in total this expression equals to 3 pi. So we found out that the area of this sector AOC equals to 3 pi square units. Then I presented to you a new formula for the area of any triangle. Here we have triangle ABC that could be any triangle. The length of side AB is a unit, the length of side AC is B units, and the angle between side AB and side AC is theta. Then according to the new formula, the area of this triangle ABC equals to A times B times sinus theta over 2. We use this formula in order to calculate the area of this triangle AOC that I copied from the original drawing. This is triangle AOC that I copied from the original drawing. AO equals to 3, OC equals to 3, and the angle between side AO and side OC is 120 degrees. So according to the new formula, the area of this triangle AOC will be equal to AO times OC times sinus 120 degrees over 2. AO is 3, OC is 3, sinus 120 degrees is equal to 3 over 2, all divided by 2. So in conclusion, the area of this triangle AOC equals to 3 times 3 is 9. So in the numerator we have 9 times 4 to 3 over 2 times 2, 2 times 2 is 4. So in conclusion, we found out that the area of triangle AOC equals to 9 times 4 to 3 over 4, and we have already found out that the area of sector AOC equals to 3 pi square units. But what is actually the area of this green shape? The area of the green shape is very easy to see from the drawing that it is equal to the area of sector AOC minus the area of triangle AOC. I repeat again. The area of the green shape equals to the area of sector AOC minus the area of triangle AOC. We have already found out that the area of sector AOC equals to 3 pi square units minus the area of triangle AOC. The area of triangle AOC equals to 9 times square root of 3 over 4 square units. So in conclusion, we found out that the area of the green shape equals to either 3 pi minus 9 times square root of 3 over 4 square units. So in terms of numbers, it is equal to 5.53 square units. Finished with the first method. Then I presented you how to find out the area of the green shape according to the second method. According to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. Repeat again, according to the second method, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. What is the area of the semicircle? The area of the semicircle equals to the area of the circle over 2. That is to say, it is pi r square over 2. R is 3, so pi r square is pi 3 square over 2. 3 square is 9, so in total this expression equals to 9 pi over 2. So we found out that the area of the semicircle equals to 9 pi over 2 square units. We have already found out in the first method that the area of triangle AOC equals to 9 times square root of 3 over 4 square units. The only thing that is left to do in order to find out the area of the green shape is to find out the area of sector COB. So first of all, we have to find out the angle between the legs of sector COB. AB is the diameter of the semicircle, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line AB point O, here the sum of the angles on the upper side of AB point O, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of AB point O? We have this angle that is equal to 120 degrees plus the missing angle. In total, they must be equal to 180 degrees according to rule number 3. So the missing angle must be equal to 60 degrees. In order to complete the sum of the angles on the upper side of AB point O to 180 degrees, this angle must be equal to 60 degrees. Then I copied sector COB in a new page and found out the area of the sector COB according to the new formula. This is sector COB that I copied from the original drawing. CO equals to BO equals to 3 units, above the radii of the semicircle. The angle between the legs of the sector is 60 degrees. So according to the new formula, the area of any sector is pi r square times theta over 360 degrees. R is the radius of the circle that contains the sector. Theta is the angle between the legs of the sector. So here R is 3 and theta is 60 degrees. So the area of sector COB will be equal to pi r square. R is 3, so pi r square is pi 3 square. The angle between the legs theta is 60 degrees. So it is 60 degrees over 360 degrees. 3 square is 9, so in total this expression equals to 9 pi. And 60 degrees over 360 degrees is 1 over 6. So in total this expression equals to 9 pi over 6. We divided both the numerator and the denominator by 3. 9 over 3 is 3, so in total this expression in the numerator is equal to 3 pi. 6 over 3 is 2. So we found out that the area of sector COB equals to 3 pi over 2 square units. Now we can find out the area of the green shape according to the second method. I repeat again, the area of the green shape according to the second method equals to the area of the semicircle minus the area of triangle AOC minus the area of triangle of sector COB. Again, the area of the green shape equals to the area of the semicircle minus the area of triangle AOC minus the area of sector COB. The area of the semicircle is 9 pi over 2, the area of triangle AOC is 9 times square root of 3 over 4. We found out that the area of sector COB equals to 3 pi over 2. 9 pi over 2 minus 3 pi over 2 is 6 pi over 2, so in total the area of the green shape equals to 6 pi over 2 minus 9 times square root of 3 over 4. 6 over 2 is 3, so in total this expression equals to 3 pi. So So I found out that the area of the green shape equals to either 3 pi minus 9 times root of 3 over 4 square units, or in terms of numbers, it is equal to 5.53 square units. Okay, thank you very much.